Here we go, guys. All right, so we're looking at example 2, part C. And again, please watch these in sequence. I think it really helps. So anyway, this is pretty simple here. In part C, we have already set up the fact that we've surveyed 20 people. 1/9 of the general population is left-handed. That's considered success, the way the question is worded. And then 8/9 would not be left-handed. The question simply is determine the expected value. This is a situation where you just have to trust the smart math people of the world. If you would look at your notes that say mean, variance, and standard deviation, you will note that mean, otherwise known as expected value, for a binomial experiment, smart math people have figured out. I think this one, by the way, has some intuition that we'll talk about in a minute. But the mean, which I'll remind you can also be called mu, and in the language or in the symbolism of a random variable, we call it the expected number of left-handed people, the expected value of x, and simply it's n times p. So if we apply that formula that smart math people figured out, I think I could have figured this one out, by the way, you would simply take 20 times 1/9. Let's stop and think about that for a second. If I told you I have a group of 20 randomly selected people, and suppose 1/9 of the general population is left-handed, how many of those 20 people would you expect to be left-handed? And you would probably tell me, I would expect 1/9 of those 20 people. That's 1/9 times 20. All right, and 1/9 times 20 is basically 2.22 repeating, I'm pretty sure. I wrote this down. Yeah, so yes, that would be the average number of people in a group of 20 that would be left-handed. That's how many you would expect. All right, so I think that's pretty intuitive. Maybe not. If not, just do the formula, okay? Part C, that's part C, pardon me. Part D, it says find the standard deviation. Well, let's see. We've done this before. When somebody asks us to find the standard deviation, what has that forced us to do first? Find the variance. Find the variance, that's right. I'm not sure where these voices are coming from, but you're right. Find the variance first. That's how you get standard deviation. So the variance, smart math people, gotta admit, I don't know where this one came from. I probably learned at one point in my life, but I don't know. But I want to remind you that a symbol for variance is the Greek letter sigma squared, and in the context of a random variable, we call it VAR of x, okay? This formula doesn't really have much intuition built into it, but NPQ, when you apply it to this, would be 20 times 1/9 times 8/9. Crunch, 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 calculator. And that variance turns out to be approximately 1.975308,642. All right? And now remember, the question was to find the standard deviation. So if you have a variance, how do you find the standard deviation? You take the square root. That's right, you take the square root of that previous answer, correct? And so if the formula for variance is NPQ, wouldn't it make sense that the formula for standard deviation would be the square root of the NPQ? In other words, the square root of that previous number. So the square root of this would be symbolically sigma, otherwise known as the standard deviation for our random variable. And this would be basically the square root of that 1.97 and so on. And we've talked many times before that if you have a number in the calculator and you wish to perform another operation on it, you simply retrieve that previous answer. But either way, it turns out that if you take the square root of that previous number, we will get something along these lines. There you go. And I hope those numbers stayed in the frame. I just realized that they might fall outside the frame, and I'm a little nervous about that. But I hope it worked. In case you can't see it, that standard deviation is 1.405456738. I don't care how many digits you keep. Let's keep it simple. All right? So there you go. That's how you find the mean, the variance, and the standard deviation for a binomial distribution. Thank you.